All right, so this is going to be the notes for 10.2. This is the last thing that we have time to talk about in our class here, and it's going along with some of the things that we were talking about in the past few days with statistics, and that is the mean and standard deviation. So hopefully you guys were able to watch that video that was posted on Google Classroom from a company called Skew the Script. They make good lessons and explain a lot of topics in statistics that can be a little challenging to understand. So for today, we're going to be talking about two of the things that they brought up in that video, and that is mean and standard deviation. And then date today is the 14th, if you'd like to add that. So first off, you've heard the term mean before, hopefully, most likely in middle school math. But the mean, just as a reminder, is the average of a set of values. Mean is just referring to the average of all the values in a data set. And I know it had a strange looking equation on that video from Skew the Script, but in general, it's exactly what you've learned before. To find the mean, all you do is you need to add up all the values. So I could say sum of all the values divided by how many there are. So I guess we could say amount of values. Right? Add them all together, divide by how many there are. So that part hopefully is familiar to you, and hopefully it's fairly straightforward. Other than wanting to know where the center of a data set is, it's also important for statisticians to know how spread out the data is. And so that's what we were talking about with that idea with standard deviation. So standard deviation is how far the values typically vary from the mean. How far the values typically vary from the mean. So when we go to find this value, it's a strange looking equation. So if you got thrown off a little bit by the symbols that were thrown in there, that's okay. I'm going to show you guys how to do this by hand, and I will show you the equation again, but then I'm really just going to show you how to do it on the calculator, so hopefully that helps for you to find that a little bit easier. But just as a reminder, that equation was what we call S of x, which is standing for standard deviation of some variable, and it's found by taking each individual x value, which is denoted by xi, subtracting the mean, which we call x bar in statistics. And then once we found that difference between them, what we need to do is we need to square all of those values so that the negative ones don't cancel out the positive ones. Because if it's further away on the negative side or the positive side, it doesn't matter. I just want to know how much it typically varies from the mean. So I do that with each individual value, I square it, and then I add them together. So this was a confusing symbol you probably saw, which was the sigma symbol, which is basically just saying we take all the values and add them all together. And then finally, once you have all those, that is all divided by divided by n minus 1. And then last step, since we squared all the values, the last thing that we need to do is we need to take the square root of all of that. So very strange looking equation, and like I said, we'll do this by hand once, and then I will just show you guys how to find all these values in your calculator, okay? So let's talk through some questions related to mean and standard deviation. So the first one is, let's say we have the simplest data set I can come up with. Data is collected and the values that we get are 1, 2, 3, 4, and 5. Calculate the mean and the standard deviation. So starting off with the mean, I could say the mean equals, or another way of saying this other than mean is I mentioned we have this symbol that we use. It's called x bar. So either way, as long as you're saying the mean equals. And then what do we do? Well, we simply add all the values together. So 1 plus 2 plus 3 plus 4 plus 5. And then we divide by how many there are. So 5. So when I add all the values on the top, I end up with 1 plus 2, so 3, plus 3 is 6, plus 4 is 10, and then plus 5 is 15. So 15 divided by 5, which is 3. So that is what the mean is here. So we found that. And then for the standard deviation, like I mentioned, it's a little bit more confusing. What we're going to have to do is we're going to have to take each individual x value, and do some different calculations with them. So we'll start off here with the first value of 1, and we're going to take that individual x value, we're going to subtract 3, which is the mean. Then we're going to square that result. We're going to divide it by n minus 1, and then finally we will take the square root of that value. Or I guess I should say we'll take the square root at the very end. And then plus, same kind of idea with the second one here. So I would have 2 minus 3 all squared, and then divided by n minus 1. And then do the same thing with the rest of the values. So 3 minus 3 all squared divided by n minus 1 plus 4 minus 3 squared over n minus 1 plus 5 minus 3 all squared over n minus 1. And I've been writing n minus 1, and I've been mentioning this variable n, and I suppose I glossed over what that is referring to. That's referring to the number of values that we have, or the amount that we have. So we have 5 values here. So I guess in all these places, really, I should be saying 5 minus 1, and so on and so forth. 5 minus 1 for all of these. So we're going to do this for each individual value. We're going to add all these together, and at the very end, since we have squared something throughout the whole problem, at the very end, we're going to take the square root of everything. So this is what it would look like. So let's take these one at a time here. So 1 minus 3 gives me negative 2. Negative 2 squared gives me positive 4. And then over 5 minus 1, which is 4. Plus the next value here, 2 minus 3 is negative 1. Negative 1 squared is positive 1. So plus 1 over 4. Plus, next value here, 3 minus 3 is 0. If I square that, it is still 0. And then over 4. Same thing with the next one. 4 minus 3 is 1. 1 squared is 1. And then over 5 minus 1, which is 4. And then finally, 5 minus 3, which is 2. And then if I square it, I end up with 4. And then on the bottom, 4 as well. So I have all these fractions here. These can all be added together, and kind of goes back to the idea that we talked about with adding fractions. I can do that as long as the denominators are all the same. So I add these all together. I get 4, 1, 0, 1, and 4. And if I add all that together, I get 10 over 4. So I want the square root of 10 over 4. So I'm going to go ahead and type that into my calculator. You could also do the square root of 2.5. Either way, it would give you the same thing. And your final answer, when you type that into your calculator, should be about 1.581. There's not really a rule for how much you should round off, but I would say rounding off the decimal to 2 or 3 places is fine. So we've got our 2 final answers, found the mean of 3, found the standard deviation of 1.581. Okay, so I mentioned this. I would prefer not to do all this by hand each time, but I just wanted you to see how it's being calculated. And then to show this, I can actually show you how this would be done in your calculator as well. So let me see if I can get this to show up on the screen here. So what I would need you to do is you'd have your calculator, and since we're dealing with statistics, you would want to hit the button that says Stat. So I'll go ahead and hit Stat. I get a menu with a bunch of different options here, and I actually want the first thing that it's already set on, which is Edit. So this is off your screen, but I'm going to go ahead and hit Enter on that. And what I have is I have a bunch of different lists in here that have a bunch of different values because I've used this for my statistics class. And I actually want to clear out all these values, and I can do that all at once by going up to where list 1 is highlighted, so L1, and not hitting delete. Don't hit delete because it will cancel out that entire list. I'm just going to hit clear, and then again, this is going to be off your screen, but I'm going to hit enter. And now everything is cleared out. And then I'm actually just to kind of clear all this out for you guys so you don't have to see all those other values. I'm actually going to do that with every list. If there's something in list 1 on your calculator, I would recommend just clearing that out. So go up, hit clear, and hit enter. So now if I wanted to find the mean and standard deviation using the calculator, I can enter in my data set. So I'm going to hit 1, and then I'm going to hit enter. And then I'm going to type in the rest of the values, 2, 3, and after each of these, I'm just hitting enter, 4, and 5. Okay. And once I have this, what I can do with this actually is I can go ahead and do some calculations. To do that, I'm going to go ahead and hit Stat again. And this time, I'm going to arrow over to the button or the area that says Calc. And then I want the first option that says one variable statistics. So I'll go ahead and hit enter. I want to make sure that list 1 is entered in. If it's not, for instance, if it said list 2 or something else, you can actually get list 1 by hitting second and then the number 1 on your calculator, and that will change it to list 1. Frequency list you can leave blank, and then if you hit calculate, we'll see those same things that we saw. X bar, or in other words the mean, is 3, and then standard deviation, remember I said that's S of X, and that's that exact same value that we found, 1.581. So anytime you need to calculate mean, and really anytime you need to calculate standard deviation, use this function in your calculator here. Okay, I'm gonna go ahead and take that off the screen now. All right, so now let's move on to just a couple more examples and then we'll be done for today. So example 2, let's say we have a coach that recorded the race times of each track member for a 400-meter race. Find and interpret the mean and standard deviation of the data. So now that I have all this information and I know how to use my calculator, I'm gonna go ahead and actually do that. So I'll go ahead and get my calculator pulled up on the screen here. I want all those values, and so I'm gonna go ahead and hit stat. And then I'm going to enter all of these into the first list. So remember, to get to the list, you hit stat, and then you just hit enter on the first option. So I'm going to go ahead and clear this out so that I'm creating a new list with some different values. And I'm going to go ahead and just start typing all these in here. So I see 57.1 and hit enter. I see 59.3. And as I'm working through this, if you guys want to pause your video where you can see the values and then just enter all those in, feel free to do that. 54.6. Sorry that this is off the screen a little bit. 55.2. Oops. 55.2. And then I'll enter in the rest of these here. Try to see if I can view all of these, the rest of them at once. 55.9, 54.9, 50.3, and 53.5. So again, I could probably trust you all to find at least the mean of all these numbers, but with standard deviation, I definitely want to use my calculator. So I'm going to go ahead and have all these values entered in, and then we're going to do that same process. We're going to go to stat, we're going to arrow over to calc, and then I'm going to choose the first option, one variable statistics. And I still want list 1 here, frequency list can stay empty, and hit calculate, and I have my mean, which is under X bar, so 55.1. And then standard deviation, which is about 2.624, let's call it, if we round that up. So I'm going to go ahead and write that into my notes. Mean, or X bar, is 55.1. That's the average race time. And then standard deviation, I'm actually going to write this below because I'm going to leave myself some space to do the second part of this question, which is interpreting the values, or in other words, explaining what they are telling us. So standard deviation, I'm just double checking, that was 2.624. 2.624. So we found the mean in standard deviation, and the other piece that it says here is it says interpret, or in other words, it says explain what that value tells you. So the mean is pretty straightforward. It's the average time, so the average practice time. So I could just simply say the average practice time, let's say, is 55.1, and then it looks like the unit for this is seconds. So that is what the average tells me, or the mean tells me. It's the average practice time. And if I wanted to be even more specific, I could say these are the 400-meter times. So that's the first part. And then standard deviation, if I want to explain what that is telling me, I can go back to what the definition of standard deviation is. The definition says these are how far the values typically vary from the mean. So I would pretty much use that exact phrasing. I would say the values, so in this case the practice times, and then I'm going to use that phrase, typically vary by whatever my standard deviation is, which is 2.624. So the practice times typically vary by 2.624 from the mean. That is how I explain what standard deviation tells me. It tells me how far the values typically from where the center is. Okay? All right, let's do one more example, and then we'll be good for today. All right, last one here, example 3. It says, of these following dot plots, which represents the data that has the greatest standard deviation? So this is actually a question that's similar to what you would see in AP statistics. It's saying, now that you understand what standard deviation is, could I answer a multiple choice question off of it? So standard deviation, like we just mentioned, is telling me how far the values typically vary from the mean. So if I want the greatest standard deviation, it means I want the values to be spread out as much as possible from the mean. So when I look at these 5 different options here, option A, the values are spread out pretty equally, and it looks like the mean or the center of all these would be right here, halfway in between 0 and 10. Part B, it looks like they're spread out a lot, and again, it looks like the middle or the mean or the average would be right at the middle of this. Same thing with the rest of these. It looks like the middle or the average of all these values is all going to fall right in the center. So which option has the greatest standard deviation, or which option is spread out the most? That would be option B. There are tons of values that are spread out really far away from the center. Every other graph has at least a few values that are pretty close to the center. Okay, dot plot D is pretty close, but B is more spread out, so that would have the greatest standard deviation. All right, that is all the notes that we have for today. Rest of time, you need to be working on the 10.2 practice, and if you have any questions, hold on to them, and I will answer them when I get back.